In this highlights video, we'll give you a quick run-through of how to use Studio 3T's Query Profiler to improve a query performance issue. Now let's imagine a scenario where a colleague calls to tell you that your website application is running really slowly, and they've established that the server is running fine, no problem there. So the next candidate to troubleshoot could be an issue on the database end. Let's fire up the Query Profiler and find out what's going on. So our web application is an interactive archive of Chicago crime stats. So let's first select the Crime Chicago database in the list, then open the Query Profiler from its icon in the global toolbar, or you could just right-click the database and from the menu select Query Profile either way. Anyway, it opens in its own tab and you can see at the top which server connection we're using and which database we've chosen to work on. Now let's switch the Profiler button to On. This instructs the MongoDB Database Profiler to start collecting data, and there's a little dialog to remind you to turn it off later because it does have an impact on database performance and disk use. So don't forget, when you're done, do turn it off. In the summary panel at the top, we can see all the queries that took longer than 100 milliseconds to run in the selected time period. You can view slow queries going back as far as 30 days ago. But right now, we're only interested in finding queries that were run in the last 30 minutes, because that's when the impact on the website was. And we're also only interested in queries against the crimes collection. So let's narrow our focus by selecting the crimes collection from the drop-down list. Now, to sort the queries by duration, just double-click the maximum duration column header. And we can bring to the top of the list the slowest query run in the last 30 minutes. To the left, in the count column, we can also see how many times this precise query has been run. But it might be more useful to group the queries by query shape, because MongoDB uses query hashes to cache and then reuse successful query plans. And this means that you can group slow-running queries according to the broad shape of the query, making it much easier to track down all the faster and slower variants of the query and solve performance issues more quickly. So grouping by query shape, we can see that one particular query is getting repeatedly run with a sum duration of over 2 minutes, and this could well be what's causing the performance problem. So let's select the repeat offender, and in the panel beneath we can now drill down to see the details and variants of queries that have been run and how each of those have performed. And in the keys examined column to the right, we can see that no keys were used. While this suggests one thing, a missing index. So if we move to the right to the code panel and open the Explain Plan tab, we can confirm the hunch. On the furthest right, we can see that the first step in the Explain Plan is a full collection scan of the entire 1 gigabyte of the collection. Now, that is going to massively slow down proceedings. So next to the Explain Plan tab is the Query Code tab, which shows us the exact query code being run. And we can see it's a very basic sort operation. And the field being sorted on is case_number. Well, looks like we should add an index to the case_number field. In other words, help the query engine to look there first and reduce the amount of data that it's querying. So in the collection tree, right-click on our crimes collection and select Add Index from the drop-down. The Index Manager now asks us to name the index, add the target field or fields, and finally, create index. It may take a few seconds to process this depending on the size of the index being built. But yes, we can confirm it's been successfully created here in the indexes under the collection. So let's see if it does the trick and speeds up our query. Back in the code panel, click on Open in IntelliShell. This loads up the relevant query code in your preferred editor. Now just run it. And here we can see it's a lot faster. Going back and refreshing the Query Profiler summary, we can see how our freshly tuned query is running at a much faster pace. And in the explain plan below, we can reveal that the query is indeed using the case number index that we just created. Finally, in the keys examined column, in the drill down panel, we can see that the last time we ran the query, it examined over 2 million keys via our new index. That straight away suggests it's because of the skipped documents value in the query, which is also over 2 million. If we reduce the skip, it'll run even quicker. So let's open the query in our editor, reduce the skip size to 200,000 and run it one more time. Refreshing the query profiler shows us we've now got the runtime down to 173 milliseconds. In summary, with one pass of a simple performance circuit, we've achieved 5 things. We found a slow-running query, we diagnosed a missing index, we created that missing index, we identified and edited a problem in the query, and we thereby demonstrated a 70-fold increase in the speed of the query. And faster running queries means getting more done at lower costs. All thanks to the Studio 3T Query Profiler. And we're only just getting started. Check out our next video for further tips on getting more from MongoDB with the power of Studio 3T.